Nothing for me. Thanks.
Okay, I see there's a question. Will the recording from Tuesday being posted? Jessica, do you want to respond that? Usually we post the recording. Yeah, we will follow up. And if you didn't find that, and I believe we record every training session. So I guess we will start. Let me share my screen. Studio. Okay, I probably turn off my camera. So it looks okay to everyone, my screen. Do I need to zoom in or?
This is good.
Okay, thanks. Yeah, so to start, I just create a new script file and I will save it and save this current file as, I guess this one. Okay, so in my script folder, so you can see this week 5-2. Okay, well, let me open the training materials. All right, so for today, we're gonna learn another data structure list. We actually already briefly mentioned about this data structure in the first week. And we're gonna have a little bit more in-depth explaining about this data structure. And after that, we will learn, I think, 3 functions that is in the apply family of functions. I feel those are very useful, especially you are trying to write loops where it applies to a list or a vector. And instead of writing a for loop, probably you can use this apply one of the apply functions. Okay. And so list is a special type of a vector, I would say, or maybe vector is a special type of a list. And it is, I mean, this list, you can provide multiple different types of data inside and with different lenses, right? If you look at the training materials, I have like a picture there, right? It could be each element can be very different, right? It can be a single value or it's a vector or data frame or even matrix. And so how do we create a list, right? We use the list function itself. The name is the same. And okay, let me write a note. Okay, usually I always import a library. Okay, I think for today we probably want to do, I mean, tidyverse is always what I want to import for each of every project and this janitor function. Okay, so let's import 2 libraries. Okay, and run it. And okay, so the first session is list. Okay, and we do some very simple practice. Simple code to practice how to learn more about a list and how to create a list. And the first one is, for example, we can create a list, for example, called X, right? This is a assignment operator and give the name to the list. Okay, the function we call the function list parentheses. Okay, we give the maybe 3 elements inside of this list. One is maybe a numerical value, another is a character, and then a Boolean data type, right? Maybe, or you can call it the logic. Okay, so now we create a list, and in the environment of you can see, right, there's a X being created. And so this one, put a notes, create a list, right? And so if you type class X, right, it will, I mean, in the console, it was as a list. That means we just create, so the data type of this is a list, right? And we learned about how to subset a vector, right? Using the bracket, right? And similarly, so if we do, for example, if we want to know what is the second element of a list, right? We can do the similar. X2, the return looks a little bit, different, right? It does not provide X. It didn't return X directly here, right? Instead, the return is always a list. So it has one element of this list. And I believe we previously introduced, right, the index, right? Vector or list. If we subset a list or index, we use its index, right? And the indexes always start with 1 for R. I believe some other programming language like Python could start with 0, right? So that's the difference. And for R, it's very easy, right? Second element, we use the index of 2. If you want to get the value of the second element, right? We actually use a nested, maybe we'll call it double bracket, right? Okay, if we do it this way, right? Okay, I should not overwrite. Let's do that. Okay. Subset list, right? This is to extract the value. To extract the second, to extract the value of the second element of a list. Okay. And let's see the next one. We have another a very small exercise. Okay, let's define another list. X list, maybe 1, 2, 4. This is a vector 0.6 and a character vector and a B. Okay, and then Control Enter. So this is another simple list we just created, and it has different elements. We can take a look at how it looks like. All right, so in the console, right, it shows what's the element, what's the value of each element. So this is small. Okay, let me save it. Okay, click the same, save. And then the small exercise is how to extract element A in the list X, right? Element A, if you look at here, right, it's the value A, right? It is in the third element of the list, right? If we want to extract third element, right, we use this, right? We use x1 double bracket and 3 and put the index 3. That basically we extract a vector, right? Then the next is to get A, we actually, okay, put the index of that vector. It should be 1, right? So furthermore, if we want to extract A, you put another bracket. Okay, 1. Okay, this is how we get the first element. Of course, you can do it for the second element for B, right? This is a create a new list. And this one is going to extract the first value of the third element of a list, or x1. All right. Okay, save. Yeah, it's always good to save what you just type it. And we can also create an empty list and with the predefined length using the vector function. Sometimes it can be very useful to create a empty list or vector so you can append the values. You can create an empty list like a bucket, right? Then you can put things inside. So So how can we create an empty list? And for example, we give it a name like a Y. Okay, let's create an empty list. Okay, Y. This is assignment operator vector. Okay, here we specify the structure type is list, and then length equals 5. So it contains 5 elements. And we just create a Y, and we can print Y to see how it looks like. Okay, there's
Min?
nothing inside. Yes.
Sorry to interrupt, but somebody requested that you zoom out a little bit. So I think so
Oh,
that they can see your notes and your code.
yeah. Is it better now?
Yeah, it's much better.
Okay. Okay. Thanks to this.
Thank you.
Yeah, you're welcome. Thank you. Okay, let's continue. So now we just print it, right? There's it's empty. And we can check what is the length, right? You can call the length function. Length function is usually used to check how many elements inside a vector or oh, sorry, it's 5. I want to check Y. Okay, so if you look at this, right, there are 5 elements inside of this empty list. And vectors. And vectors can be converted to list using as.list function. And we can practice typing, right? Using very simple 1, 2, 3. Okay, so for example, we create if you still remember, right? We use C parentheses this function to create a vector, right? And we can check what is graph. What is it? It actually provided the numeric, right? It is a vector, but it is a numeric vector. So that's how we see numeric. And now we can maybe do Z1 as dot list Z and control enter, right? Run it. And now check the data structure. It becomes a list right now, okay? Okay, this one is convert a vector to a list, okay? And this one is create a vector, and the class is check the data structure. All right. Okay, so we are good? Any questions so far about the list? Yeah, sometimes we're gonna use list. I use list a lot, especially do the string split. So maybe in the next week, Jessica gonna talk about how to manipulate the strings. Sometimes you're gonna split the strings and try to extract certain elements of a string. So that at that moment, you probably will use this double bracket to extract certain elements of the splitted strings. I feel that can be it's a commonly application in that case. All right, so those are the lists. And next, we are going to learn the apply functions. Okay. So we previously, I think last week, Sebastian talked about, teach about the for loop, right? You can loop if you want to apply the same functions to different values, right? Basically, you want to write a for loop to do that. And apply functions is actually do something similar, right? It's just do it in a easier way to write the for loop. Do something similar to apply a function to each element of vector or list. And it's a more compact format, and so it could make your code easier and to read and understand. So we are going to introduce 3 functions in this family. Like the first one is I call it lapply, second is supply, and the third one is apply. So lapply takes a vector or list as the and apply functions to each element of a list or a vector as the input, right? So it takes a vector or list. And supply is similar. It also takes a vector and a list. The difference is the output of apply is always a list, right? It's a list in and list out. Even a vector in, the outside output is still a list. But supply is a little bit different. It always try to give you the simplified data structure of the result. Okay, we will see how they are, I mean, using some simple examples to see the difference as well. And apply function is the input, it can take the arguments, right? The first arguments can be a data frame. So you can specify apply a function to each row of a data frame, or apply that function to each column of that function of that data frame. So you probably can imagine this can be quite useful, right? So you don't have to write a for loop. Okay, the first one, 2.1 is the apply function. So we're gonna learn the basic structure or how to the usage of this function. So so how does it how it works? So it will loop over a list or vector and iterating over each element and apply a function to each element and return a list. The basic structure is very simple, like many other functions. I mean, it's basically the same as other functions, right? You just type the function name and parentheses and the first element. First element is x should be a list or a vector, and then your function, right? Function names, right? There are some other things behind it. For example, if your function takes more than one arguments, right? So the first arguments will always be one of the elements of x. Well, the other arguments you're gonna provide it here, separated by comma. Okay, so this one maybe I can do the argument 1, argument 2, right? Of this function, right? Okay. I would think it's always much easier to use some examples to better understand what this function can do. Okay, so let's try a simple function, and of course I always use X, but you can do a different name. Okay, list. Okay, and okay, remember list is the function where we create a list, right? A equals 1, 2, 5. E R norm. Actually, I prefer this one. It's easier to read. R norm is a function where we can generate a random, normally distributed values, right? Let's give 10. That means we're gonna create a 10 normally distributed random numbers. And C, okay, C is a vector. We create a vector, 1, 2, and A, and 7. Okay, and we are making a missing value inside of this list. X, you can view X to see how it looks like, or print it. Okay, this is a list, right? It's for A, it has 5 elements, and B 10 elements, and C has 4 elements, and it has the numbers being provided here as well. So what we are going to do is we're gonna calculate the mean value of each element of that list. So you probably know that, right? If we want to calculate the mean value, previously we introduced, okay, so the first argument is X, right? This is the X, the list, and then followed by the mean value. The function, right? It's a function. Okay, let's see what's the output, right? The output is a list, right? Then it contains, it's a 3 elements list actually to calculate mean value of each element, the previous element x. So the value has 3 minus 0.06 and an NA, right? We do remember, right? If we did not specify remove missing value, it will calculate that missing value. I mean, it will include the missing value in the calculation and always returns as a missing value. So what we are going to do is we actually want to add the second argument, right? NA remove equal to true, right? Let's try this again. Okay, this time, right, we do get a value for the third element, right? For the mean value, it does remove the missing values. So this is how we, okay, let's see, put a note, right? Create a sample list. And this one is used to apply mean function. Okay, this is apply mean function. Oh, we can say calculate mean values of each element in X. Okay. Okay. Next. Okay, there's one more thing where sometimes you want to save the result, right? And what I'm going to do is trying to see what is the data structure of the output of a NumPy, right? It is called list, right? That means the output is always a list. Okay, let's see. And sometimes, I mean, if the functions, if the function here after the function you are going to apply to a list, if it is very simple, probably you don't want to define it, right? You don't want to give it a name as we call it an anonymous functions or like a temporal functions where you just use it in this apply functions. Once they call to apply function or supply function is done, the function disappeared. And sometimes people like to write that way, but I would think maybe let's try to take a look at that and get familiar with that. I don't like that approach. I always define a function, but it's good to know. Okay. So we're gonna learn this using a simple example. So this example we ask to extract the second value of each element in a list. Okay, and let's first create a list first. Okay, we can call it a test list. Okay, we have different elements. Run if 5. Okay, create some 0 to 1 random numbers, and then create normally distributed numbers, and then C is a character vectors. Okay, so we have A, B, C, D, whatever. Okay. Now we can print and to see how this. Okay, if you print it, this is the test list we just created, right? It has different elements. The task here is try to extract the second value of each element. For example, 0.68, and this is second value, and the B is the second value of the third element. And if you don't write a function, right, what we can do is we could potentially Oh, this is simple. And let's see, 2. Oh, it works, right? You can use this $sign, right, to get the each element. And also you can do, for example, first one, this is the, and second, right? Yeah, they do the exactly same thing, right? To extract the second value of an element in a list. Okay. Okay, this one works, but you have to do it one by one, right? Or another way is you can write a for loop, right? Write a for loop and loop through each element and then get the values. Or maybe we can write a for loop here to refresh your memory, right? For I in test, right? This is the basic formatting of for loop, right? For, after for, there's a bracket. This is how you iterate, and then a curly bracket, right? For I in test, so we want to do print I 2. Let's see how that will work. Okay, we write a for loop, right? It will print the second value of each element. This is how we do it using for loop. And we can also use this apply functions, right? X and function. Okay. Oh, hold on. Okay. It should not be X. It is test, right? That is the thing we want to do. That's it. And list we want to apply. We want to extract the element and I 2, right? Okay. So in this case, we actually have a function, right? We actually define this function. We didn't give it a name. So this is likely a temporal function, right? That has no name. And once we are done with apply function and this function disappeared. Okay, I would think it works if it's very simple, but usually if this function has more than 2 lines, I try to give the name and write it outside. Okay, and this is the use for loop to extract values. Well, this one is do the same thing, but we use a different approach, right? Apply function to extract values. I mean, basically it functions the same as a for loop. In the training materials, I actually define that functions. So basically what you can do it to make it easier. So you can copy this and you can give it a name, F, right? Function, and then control enter. Now in our environment panel, right? There's a function F being created, right? Okay, now you can apply this one. Apply test F. Okay, right? It does the same thing. Okay, those are just different ways how you can do that. I mean, it really depends on personal preference, right? I just prefer define the functions, always define it. Okay, save it. Okay, there's an exercise. We can save it. Yeah, after we done the other 2 functions, we can go back this exercise. I guess we probably you still have time, so we can practice this together. And the second one is the second functions, we call it the supply functions in this family. And we already, touch base a little bit. So everything's the same, like Laplace function. The usage is the same and the formatting is the same. And the only difference is the output. The data, the output structure can be different, right? So we can give a try. Let's see. Maybe do we have anything? Let's use this one. I will copy to here. Okay. We can use a example list to show how that will work. Okay. Or you can rerun the previous lines for this X. So basically you can have an example, a simple simple list. And what we are going to do is we do it output 1. So let's try to save the output. Apply X mean only removal equals to true. Okay, and this is 1. And let's do the second one. Output 2. Okay, you can. Oh, we want to compare the difference. X mean and a removal T. Okay. Now let's run this too. Okay. If you look at here, if you look at the environment panel, right? Output 1 is a list, right? Output 2 actually is a vector, right? They actually were put into different section of this panel, and we can print it to see how it looks like. Print output 1. Yeah. So you see that the output has a structure of list, right? And we can always call class, right? If we class output 1, right? In the console, it shows a list, right? That means the data structure is a list. Well, how about output 2? Okay, and it's printed. It's 3 values, right? It's more likely the format is more likely a vector instead of a list. Yeah, it's numerical vector. So from this simple example, you can see the difference, right? The usage, the structure, are very similar, and the only difference is the output are different. The format, the data structure of Laplace is a list, and the supply is whatever format they are can think about. That's as simply as simple as possible. If it has to be a list, maybe it will give a list. Yeah. Okay, so this is about supply. Output. This is a list. And the output is a vector. Okay, those are the difference. And let's see the last one, apply function. So apply function is we mentioned about it can take a data frame, right? And apply functions to each rows or to each columns. So let's see how we can specify when to apply to row and when to apply to the column. Okay, and I would think it will be good to first define a data frame, because this one input is a data frame. So if you still remember how to create a new data frame, right? The function we call it data dot frame parentheses, right? Then, for example, column 1, this is column name, column 1 equals to 1, 2, 3, right? Data frame always has the same length, right? So each column should have 3 elements. based on the first one. So the other columns should have the same length as the first one. Column 3 equals, okay, 7, 8, and A, and give a missing value there. Let's save it. And we see, okay, here in the environmental panel, right, we have a new data frame A. If you click that, and then it will show all the elements of this data frame, right? C1, C2, C3, and each element. What we are going to do here is we try to, let's define a function, right? In the training materials, I did not define that functions and just use it inside of apply functions. So let's define a function to like, okay, here what we am trying to do is to calculate the product of each row and also calculate the product of each column. So let's define a function to get product. Okay, so function, we learned about how to define our own function, right? Function parenthesis x, right? It's the one column. For example, what we are going to do is product x and a removal equals to t. Okay, this product PROD product function is a function where you can calculate the product of a vector here. Let's take a note. Create a function to calculate the product of a vector. Okay. Okay. Once we are done with this, let's run it. So now we have another function, get product, as shown in this environmental panel. So it's ready to be used. Okay. First, we will calculate row product. Okay, what we can do is apply, right? It takes data frame. In this case, it's A. And here, we use 1 or 2 to simplify, to tell this function we are going to apply this function to a row or a column, right? If it is a 1, that means it will be applied to each of this row. Get product. Okay, after that, it's a function name. For our case, we have more than one argument. So we will put this argument after the function name. Okay, that remove equals to true. And that remove. Oh, did I? Okay. A get product. And a. Oh, by the way. Okay. Do you see that? There's an error. It says error in function unused argument. For my case, I provided na.removal equals to true. But in our function, when I define this function, right, I actually only have one argument. That means I should not put this here, right? It has already been considered here, right? So let's try it again. All right. So this time you see, right? It actually calculate. Let's see. For first element is 28, right? So 28 is the first row, right? 1 times 4 times 7, that gives 28, right? And the second one is 2 times 5, 10, 10 times 8 is 80, right? So we have 80 as the second value, the third one, yeah. So this is how we calculate the products for each row. And next one. calculate the column product. Okay, same thing, A, well, we use 2, right? Get product. Okay, this time we basically calculate the product for each row. For example, this case, right? 1 times 2 times 3, that is 6, right? So that matches with the output here. All right, so this is the basic, I mean, the usage of apply functions. And we learned about Laplace, apply, and apply. And I actually I mentioned about in the training materials that sometimes there are better alternatives for column-wise operations on data frame. I mean, it's in the dplyr. There are many other functions available. We are not going to talk about it today. Maybe the future or next training, we may have a chance to take a look at that together. And with that, we can go back to the exercise. Okay, let's save it. Okay. All right. So this exercise, okay, let's read about that. So use Laplace function to separate and save air quality data by month. Okay. If we read this exercise, so basically what we need to do is extract air quality data in each month and save it as it didn't say ask you to save Excel or CSV file. Okay, I always save it as a CSV file. So we're gonna extract the data in each month and save it in a separate CSV file. And by month, okay, by month that gives us a hint. Okay, you probably want to create a list of a month, and then you loop through each month and apply a function, right? That function will extract data from the air quality data frame for each month and save it to a file, right? That is how we're going to do that. So the first step we are going to do is to, I would say to create a list of months, right? So let's, for example, let's view our air quality data frame. Okay, this is it. The air quality data frame we have. Okay, if you look at here, there's a column called a month, right? It has from 5, 6. I mean, it's all the way up to 9, right? So it's multiple months. And what we are going to do is create a list of months. I actually like. I don't like I don't like the column name. So what I'm going to do is save it into a different data frame and with clean names. Okay. So we are using this AQ data frame here. I mean, it's the same as air quality data, but I just have a different column name. That means a more standardized data frame name. Okay. So what we are going to do is we are going to know how many months available, right? AQ, we create a list of months, right? If you want to extract a certain column, right? We use this $sign, right? AQ $sign month, right? AQ $sign month is gonna print all the months in this data frame, but we don't need, I mean, some are the same, right? We need unique months, unique value in this column. So if we call unique, and then it will give us 5, 6, 7, 8, 9. I use this unique a lot. So to get the list of a month or list of a site or whatever, get the unique value of a column. Let's save it to a object. Okay, now we have this month list here. Later time, we're gonna apply the functions to this month list to extract data in each month and save it. Next step is create a function, right? To extract monthly data and save it as a CSV file. So, I mean, it's always good to use some simple numbers to test if that function is correct or not. So usually what I'm going to do, usually my approach to write a new function is I will start with some 1 month of data, right? For example, I define a month like this month, right? 8. If you look at that, right? AQ is 8. So if I want to extract the data in August, right? And it's maybe DF. Let's call it a different name. DF, yeah. AQ, right? And to extract the month of 8, we use a filter, right? We filter out when month equals to 8, right? Then it's I month, right? So let's see how this looks like. Oh, I forgot to take notes. Yeah. Yeah, this one is very simple. Clean names. And this one is to filter data in a certain month. Okay. Let's control C. Okay, I month. Error is I month well, are not found. Okay, that means I did not define it yet. So let's define it. Let's run 910 for my case. So now we have it should be okay. All right, let's take a look at DF. This is a month in August, right? It's always good to check your data after each manipulation. So another way is use a summary, right? Call summary, and it will provide some statistics of the DF. So what I'm looking at is this one, right? The month. So everything is 8. That means it's correct, right? I do filter data in August. So it's good to go. The next one is to save this data, right? So we can use write CSV. Okay, write _CSV is the function where we can save our data frame. So it will, the first argument is DF, the data frame, right? And next is followed by the path and the file name. For my case, I will save it to, let's see, I will save it to, I have this output folder. I always save any of the processed data in this output folder. So for my case, it will be output and then maybe df tests.csv, right? Just give it a name and then run this script. Cannot open file for output. Here cannot open file for write. Oh, that's strange. Do I have this? df. Oh, it's the same. Okay, I need to figure out why I cannot open this.
What's your current working directory?
Let's see.
Min, your output is just spelled wrong. It's OUT. You just forgot the T while you were typing.
Well, thank you.
Nice catch.
Thank you, Liz.
You're welcome.
Thank you, Liz. Yeah, it always happens. So output, right? Okay, it works. Okay, let's click that one. So if you look at my screen, right, I do have a df.csv here. That's I just saved. Okay, so seems this part of function should work. So now it's time to write our function right now. So let's define a function name like extract oh, okay, data, okay, and save it anyway. You can and function, okay, so it works. We do it imount has one argument and the curly parentheses df. I mean, it's the same thing, right? You can even do copy and paste. Oh, I would think maybe we want to do AQ here because we probably you want to apply to different data frame, right? So in this case, you can put two arguments here, and df equals okay AQ future months 9 months. Okay, after that you want to write CSV df. It's basically the same thing, right? What we just practiced. And output df the CSV. Okay, this is probably the function we want to write, but there's only one thing we need to be careful about. Be careful because if we do the df.csv, right, for each month, you're gonna overwrite the previous one. So eventually you're gonna get one file for all the months, right? That means we want to save a different name for each month of the data, right? For each monthly data. So here we can use this pest zero function. I use it a lot. So what we can do it is okay. I will, if you are not sure about what this pest zero function does, okay, do question mark pest zero, and then you will see, okay, concatenate strings, right? If you take strings and it basically it's gonna make it as one string, right? So let's give it a test. Let's give it a try here first. For example, output, what we can do is we want to use different name, right? Monthly df. Okay, I mean, you can use a different name. For this, we do want to have something different, like a imount for this case. So it will provide a different month of the data. Okay, if we run this line, okay, what we have is, okay, we have a file name with I months of 8, right, in August. For example, if we change this I months to 7, okay, and then run it again, now we have a different name, right? Monthly df7.csv. It seems to work, right? That means probably this is the better approach to save the file. Oh. All right. Okay. Now we can run this function and apply it to our data frame. In this case, it's AQ, right? No, not AQ, apply it to each month, right? Apply month list and extract data. It will take I months, but we have second argument that is AQ. So I will do AQ here. Okay, after run that, and let's check if we do have output. Yes, we do have, right? We have monthly data being saved in the specified folder. Okay, that's all about this exercise. Let me know if you have any questions. Do we have any questions in the Q&A window so far? Everybody did well?
We had a couple of questions, but the TAs handled the questions in the chat.
Okay, great. Yeah.
So there are no remaining questions right now, unless people have questions for Min right now.
Yeah. feel free to ask questions. We still have a few minutes, or you can bring your questions tomorrow. We have office hour every Friday at 1 o'clock, the same time. And I think this week is the second and last week, and next week we will done. I mean, 2 more sessions. We are done with this basic art training. Hopefully, everybody learned a lot and get familiar with R, and you are not scared of R, and you were able to at least somebody give you a code, you were able to understand what's the meaning, and even you can modify their code, or even better, you can write your own code and try to replace some of this routine Excel work. Yeah, if some of you were able to do that, that's great. Yeah. Ideally, hopefully everybody were able to do it. Yeah, I will stop sharing if no questions. And all right, I believe Jaycee will upload the recording of today's session and the previous session, and you feel free to watch. And I mean, if there's anything you missed. Okay, sounds good. With that, and hopefully we can end it early today. Hopefully everybody has a great week, and thank you for joining for today's session, and look forward to meet you next week.
Thanks very much, Min. Thank you,
Yeah.
Jesse.
Thank you.
Okay.
Thank you.
Yeah, take care. Bye.